Asteroid 2024 YR4, discovered in December 2024, has garnered significant attention due to its potential to impact Earth on December 22, 2032. Current estimates suggest a 2.3% probability of collision, equating to a 1 in 43 chance. The asteroid's size is estimated between 40 and 90 meters in diameter. If such an object were to collide with Earth, the consequences could be severe. For instance, an impactor of this size could release energy comparable to multiple megatons of TNT, potentially creating a crater approximately 1.2 kilometers in diameter. The immediate effects would include a massive explosion, shockwaves capable of destroying structures within several kilometers, and thermal radiation igniting fires over a wide area. If the impact occurred in an ocean, it could trigger significant tsunamis, posing risks to coastal regions. Historically, Earth has experienced impacts from objects of similar size. The Tunguska event in 1908, caused by an estimated 40-meter wide asteroid, resulted in the flattening of approximately 80 million trees over an 800 square mile area in Siberia. Such events, while rare, highlight the potential devastation of asteroid impacts. In response to the potential threat posed by 2024 YR4, international space agencies, including NASA and the European Space Agency, are closely monitoring its trajectory. Observations from ground-based telescopes are ongoing, and the James Webb Space Telescope is scheduled to gather more detailed data to refine the asteroid's projected path. These efforts aim to reduce uncertainties and assess the actual risk level. Mitigation strategies are also under consideration. One proven method is the kinetic impactor technique demonstrated by NASA's Double Asteroid Redirection Test or DART mission in 2022, which successfully altered the trajectory of a non-threatening asteroid. Such technologies could be employed to deflect 2024 YR4 if further observations indicate a significant risk of impact. While the current probability of asteroid 2024 YR4 impacting Earth in 2032 is relatively low, the potential consequences of such an event warrant vigilant monitoring and preparedness. Ongoing observations and advancements in planetary defense technologies are crucial to accurately assess and, if necessary, mitigate the threat posed by near-Earth objects.